All right, in this video, we are going to continue learning about Unit 1. This is Lesson 2, Theoretical Probability, which is the Florida Best Benchmark DP.2.2, which is find the theoretical probability of an event related to a repeated experiment. All right, this is what your notes will look like. This is what my students received in class. And first, let's take a look. What is theoretical probability? So this is the number of outcomes in the event. Number of outcomes in the event divided by the number of outcomes in the sample space. So what it means by the number of outcomes in the event is how many times does something specific occur in that event. So here we're going to be rolling a 6-sided die twice. What is the probability of rolling an odd number each time? So we have our sample space, and we're here going to use a table. So first we need to determine the sample space using a tree, table, or by listing the possible outcomes. In this example, we are using a table. And so I've completed this table, just like we taught you to do in Lesson 1. And because I know that there are 6 rows and 6 columns, I know that 6 times 6 is 36. So that's going to be the denominator of my fraction is 36. Now we need to determine the numerator, and we're going to do that by circling the desired number of outcomes in the event. And here, what we're talking about is the odd number each time. So count how many times an odd number occurs both times. So here we have 1, 1, then we have 3, 1, or 1, 3, and 1, 5, 3, 1, 3, 3, 3, 5, 5, 1, 5, 3, and 5, 5. So whether you highlighted or circled, whichever works for you, you would have noticed that we had a total of 9 combinations, 9 odd numbers both times. So this will make our fraction 9 over 36. Well, 9 over 36 can be simplified. So to simplify that, or to write that in simplified form, I could rewrite that as 1 over 4, because 9 over 36 simplified is 1 over 4. Now to change that fraction to a decimal, I'm actually going to do 9 divided by 36, or I could do 1 divided by 4, but in my calculator I can do 9 divide 36 to get my decimal, which is 0.25. But you could also be asked to write it as a percent. So to change a decimal to a percent, we're going to take that 0.25 and multiply it by 100. And when we multiply it by 100, we get 25%. All right, we're going to do a little bit more practice. Here there are 6 marbles in a bag. There is 2 pink, 1 blue, and 3 orange. And we want to know what is the theoretical probability of choosing 2 pink marbles. So first thing we did was we completed our table for our sample space so we could list all of our possible outcomes. Again, we have 6 rows and we have 6 columns. So we have 36 possible outcomes. Now we have to count how many times we're going to get 2 pink marbles. So anywhere that we have PP listed, that would be 2 pink marbles. And you'll notice here we actually have 4. So our fraction would be 4 over 36, which can be simplified to 1 over 9. Now to write that as a decimal, we're just going to do 4 divide by 36. And then to change that decimal of 0.11, we're going to multiply that by 100. and we get 11%. You do need to know how to simplify a fraction, how to take a fraction and write it as a decimal, and how to change that decimal to a percent. So if you are struggling with that, please make sure you are adding these into your notes. All right, you're going to try this one on your own. Pause the video and then come back and check your work. All right, so here first we're going to determine our sample space using the table. Okay, once I completed my table, I noticed that I had 4 rows, 4 columns. 4 times 4 is 16 possible outcomes. Or you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, this is asking us for the probability that A is pulled 2 times in a row. So the only time that you would have A 2 times in a row is in this top left box where it says AA. So my fraction is going to be 1 over 16. Now I have to write that as a decimal. So I did 1 divided by 16, and then I got 0.0625. And then to change that to a percent, I multiplied by 100 and I got 6.25%. Some students may accidentally write this as 62.5, but if they did that, then they would actually, what they did was they moved that decimal 3 times or multiplied by 1,000 instead of multiplying by 100. So please be careful and check your work. All right. So this is that second page of notes. And at the top, you have just a little bit of vocabulary. So dependent events are 2 events where the outcome of one event affects the outcome of the other event. You can only use the sample space method to find the theoretical probability. So remember, theoretical probability is actually in a perfect world. And we know we don't live in a perfect world, but we use theoretical probability just to figure out how often something might happen or to predict something. So that's coming later. So we've filled out our sample space for our 6-sided die. And we want to know what is the probability of rolling a sum of 5. So we have sum of 5 is 1 and 4, 2 and 3, 3 and 2, and 4 and 1. So this is going to be 4 in our numerator, and then 36 in our denominator. So 4 over 36. We simplify that to 1/9. Our decimal is then 0.11. And our percent is 11%. In this last example that we have, I think on this page, oh, not the last one, second to last one, we have 6 marbles in a bag. Now there's 2 pink, 1 blue, and 3 orange, but what is the theoretical probability of choosing the same marble? So because we want to know the same exact marble, not just 2 pinks or 2 oranges, we want to know what's the probability of pulling the same marble. So we had to label those marbles or those colors with what we call subscript. So if it's asking for something that specific, we do have to be careful, and you do have to label your sample space with 1s and 2s. Only if it's being that specific do you have to do that. All right, so the same marble, we have P1 and P1, P2 and P2, the blue and blue, orange 1 and orange 1, orange 2 and orange 2, and orange 3 and orange 3. So we could draw the same exact marble a total of 6 times. There are 36 possible outcomes, so it's 6 times 6 over 36. Which simplifies to 1 over 6. To write that as a decimal, I do 6 divided by 36, and I get 0.17. And then to change that to a percent, I multiply by 100, and I get 17%. Now, if I asked you what is the probability of choosing the same color, then we would actually have a much higher probability because we would be able to include the pink 2 in pink 1, or pink 1 in pink 2, orange 1 in orange 2, orange 1 in orange 3. So your probability drastically increases in that scenario. So be careful when you're doing your test or your fast, because if it asks you something about the same exact marble, that probability is going to be very different than just choosing the same color, because the same color is 14 out of 36 or 7 out of 18 as a fraction, or 0.388 as a decimal, or 39% would be your rounded percent. So just be careful and make sure you are reading the question. All right. Last question. If you toss a coin 3 times, what is the probability of getting at least 1 heads? So if we used our tree here to create our sample space for 3 flips, again, first flip, second flip, third flip, and we came up with all of our possible outcomes. So heads, 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 tails, heads, tails, heads, and heads, tails, tails. That's where this list is coming from. We also have tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. Well, all but one of those has at least 1 heads. The only one that doesn't have at least 1 heads is the tails, tails, tails. So our fraction here would be 7 out of 8. Our decimal is 0.875, and our percent is 87.5%. That's it. Your notes are completed.